Hello and welcome to Mathmaster. In this video, we are going to solve some practical problems based on union and intersection. But before that, let's talk something about cricket. As you know, unfortunately, India lost the World Test Championship final recently. But the good news for cricket fans is that the T20 World Cup is knocking the door. So there must be a strong team to be selected so that they will perform better in T20 World Cup. Okay, so here are my picks and I think this squad looks quite stronger. I have categorized my picked players into two categories. The first category represents set A, that is of batsman, and the second category is set B, that is of bowler, that I have picked for T20 World Cup that is going to happen this year. So that means the players in the A Union B should be playing in the playing XI. Okay, but when I count them, I found that there are total 13 players that I have picked. But the problem is that only 11 players can play a particular cricket match for a particular cricket team. And I have selected total 13 players. Okay, so anyhow I have to remove 2 players so that it will become a squad of 11 players. So to do the same, let's revisit the squad. When I revisited it, I found that I have counted Hardik and Jadeja twice. I have counted them as batsmen as well as bowlers because for me they are the all-rounders in this team. So I have named them in the batsman category as well as in the bowler category. But in doing so, I am counting them twice. So the problem is arising here. Now, as here you can see, number of elements in set A is 7. That means there are 7 batsmen I have picked. Number of elements in set B, that means the number of bowlers I have picked are 6. And adding them, I am getting 13. Okay, why 13? Because here I found the problem that I have taken Hardik and Jadeja twice. As here you can mention them in A intersection B as they are present in both the set. So if I add number of elements in A and number of elements in B, then what is happening is the number of elements in A intersection B are automatically included in this case twice. So in n of A plus n of B, the number of elements of A intersection B are automatically included twice. So to resolve the problem, what I must do is I have to subtract this just once so that I can balance this out. So I can say that number of players in A union B will be number of players in A plus number of players in B minus number of players in A intersection B. Now let's put the value and find out whether my assumption is true or not. Okay, here as you can see there must be 11 players, that means n of A union B must be 11. Okay, now this is LHS. Now count the RHS part. Number of elements in A are 7 and number of elements in B are 6. And as you can see here, the number of elements in A intersection B are 2, that are Hardik Pandya and Ravindra Jadeja. So if I subtract it, then 7 plus 6 equal to 13 minus 2 equal to 11. So in RHS also I am getting 11 and as well as in LHS I have got 11. So my problem is fixed now. Hence I can say that if there are two sets A and B, then the number of elements present in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay, so we can write that let A and B are two finite set, then number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay, but another case is that what if A and B are disjoint? Okay, that means if there are no common elements between A and B, in that case what will happen? If there are no common elements, then number of elements in A intersection B will be 0 because A intersection B will be 5 in that case. So there are no elements, that means number of elements will be 0. So in that case I can write that number of element in A union B is equal to number of element in A plus number of element in B, and this part will be 0. So this is in case of disjoint set. Okay, now let X is a set where the number of elements are 4 and number of elements in another set Y is 3. Okay, and the number of elements in X union Y is 5. Okay, so what will be the number of elements in X intersection Y? We have found out that the number of elements in X union Y is equal to number of elements in X plus number of elements in Y minus number of elements in X intersection Y. Okay, this will be equal to, here if you put the value, this will be 5 equal to this is 4 plus this is 3 minus this one. Okay, this will imply this will be equal to number of elements in X intersection Y equal to 2. So in this way I can solve the problem using this formula. Now let A, B and C are three finite sets. Okay, A, B and C are three finite sets. Okay, then in case of three sets, what will be number of elements in A union B union C? Will it be the sum of the elements in set A, set B and set C? No, it will not be the sum of number of elements in set A, set B and set C, because here if I am counting the number of elements in set A, then I am also including this part, that is A intersection B, and also this region, that is A intersection B intersection C, and also this region, that is A intersection C. Okay, similarly when I count the number of elements in B, I am also counting A intersection B, B intersection C as well as A intersection B intersection C. Okay, and the similar case for C. When I am counting the number of elements in C, again I am counting A intersection C, B intersection C as well as this A intersection B intersection C. So as you can see here, if I count it, then I am taking A intersection B 2 times. Okay, B intersection C also 2 times, and C intersection A also 2 times, and A intersection B intersection C 3 times. If I add the number of elements in A, B and C, then I am counting these sets 2 times and the intersection of all 3 sets 3 times. So definitely the sum will not be the union of all 3 sets. Okay, so for that I have to subtract the elements of some parts so that my problem will be solved. So if I am adding, let n of A plus n of B plus n of C, then as you can see from the Venn diagram, the intersection of any two sets, that is number of elements in A intersection B, n of A intersection C and n of B intersection C are included 2 times, and number of elements in A intersection B intersection C is counted 3 times. So to counter this problem, what I need to do is, as these are added 2 times, so if I subtract them 1 times, then my problem is solved. Okay, this let to this addition I am subtracting these just 1 times. But here comes another problem. Okay, let I am zooming this part. Okay, this part here. So this middle part, this is A intersection B intersection C. So if I take A intersection B, B intersection C and C intersection A one time, then what I am doing here, I am excluding A intersection B intersection C 3 times. So you can see here, as this is added 3 times, and when I subtract these terms 1 times, then this is automatically totally removed. So to make it count just 1 time, what I need to do, I have to add this once. Okay, so now my problem is solved, and I can write number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. Okay, now let us take an example and verify this formula. Let A be a set where the elements are 1, 2, 3 and 4. Okay, B be another set where the elements are 1, 2, 5 and 6, and C be another set where the elements are 1, 3, 5 and 7. Okay, so A union B union C will be the set that is having elements 1, 2, 3, 4, 5, 6 and 7. Okay, and A intersection B will be 1 and 2. B intersection C will be the set of elements 1 and 5. C intersection A will be the set of elements 1 and 3. So, and A intersection B intersection C will be the set of element only 1. So, this is a singleton set having the element 1. Okay, so now let us verify here. Number of elements in A plus number of elements in B plus number of elements in C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Now put the respective values. This will be 4 plus 4 plus 4 minus 2 minus 2 minus 2, and this will be 1, as this is a singleton set. So this will be 12 minus 6 plus 1, and this will be equal to 7. Okay, now you can see here the A union B union C set is having 7 elements in total. So here also we got 7. Now let us solve some problems that are in the exercise in this chapter. Okay, based on these two formulas. Okay, here it is given that in a group 400 people. So there are 400 people in a particular group, and among them 250 can speak Hindi, 200 can speak English, and we need to find out how many of them can speak both Hindi and English. Okay, let set A be the set of people speaking Hindi, B be the set of people who speak English. Okay, then number of elements in A is given as 250, number of elements in B is given as 200, and as you can see here the group is having 400 people. That means number of elements in A union B is 400. Okay, now we need to find out number of elements in A intersection B. Okay, so use the formula. Here you put the values, that means 400 will be equal to 250 plus 200 minus number of elements in A intersection B, and this will be equal to 400 equal to 450 minus n of A intersection B, and this will imply n of A intersection B will be 50. Okay, so our answer is 50. That means 50 people can speak both Hindi and English in this particular group. Now the second question. Here it is given that in a particular group 70 people are there. 37 like coffee, 52 like tea, and each person like at least one of the two drinks. So we need to find out how many of the people like both coffee and tea. Okay, let me denote A as the people who like coffee. Okay, B with a set of people who like tea. Then A union B will be that group of people. So I can say number of elements in A union B is given as 70, n of A is given as 37, n of B is given as 52, and we need to find out n of A intersection B. Okay, so this will be 70 equal to 37 plus 52 minus number of elements in A intersection B. Okay, then 70 will be equal to, this will imply n of A intersection B equal to 89 minus 70, that is equal to 19. Okay, so we can say that there are 19 people in that group who like coffee as well as tea. Okay.